These notes are continuing on with Geometry 3. We had just done a front and back of another page. It's in the packet. We're just continuing on lesson 9.2. Length of line segments is what we're working on here. And to help out, we're just going to do a lot of examples for our notes. So I've kind of given our X and our Y axis to help us here. X and Y. We've kind of drawn it on here. So plot each pair of points on the coordinate plane below and then connect the points to form a line segment and find its length. So there's several things you need to do. How would I do example 1? A is 6, 2, so yeah, I got to go over 6, 1, 2, 3, 4, 5, 6, up 2, and that is point A, and then I need to do point B, which is over 6, but then down 3, 1, 2, 3, point B. So then you're going to connect the points, so we've plotted them, and we got to connect the points, then we got to find their length, its length, or it's the line segment. So if I connect them with a line, how do I find the length between them? We talked about this even in the last part. We said you can just count the boxes. We did this on test 10, and there were some kids that were struggling to graph in the right spot or count the distance between. So this is a good practice here. That is 5 units. So that's an example of what I want you to do here. So then go on to number 2 and plot C and D and connect them together. So it's not like B is going to connect to C. These are all individual problems. So each one is just 2 points in connecting them. So C, you're connecting negative 4, 0. Meaning you're going to go over 1, 2, 3, 4. 0 means you don't go up, so there's point C. D is over 3, 1, 2, 3 this way, but then not up, so there's C to D. And then you're going to connect those, and then what's the distance between them? 1, 2, 3, 4, 5, 6, 7. So then this would be 7 units here. So you've got A to B, and I might do that one here with black and then show A to B is that one, and then in green I did C to D. Maybe just color coordinate so that you can see the difference between each one. So now you're ready to try E to F and plot these points and distance between them. Just lots of examples. Negative 5, 3. So negative 5, 1, 2, 3, 4. Negative 5, up 3, 1, 2, 3. So that would be E. And then F is 1, 3, so over 1, up 1, 2, 3. So I think it's helpful to have your finger here to point and then being able to graph. So connect the 2 points together, and then what's their distance between them? And so those are 6 units apart. And that one was in green, so maybe I switch back to G and H. I'll use black just so I can see those. Negative 2, 3. So to start at the origin, negative 2, and then up 3, 1, 2, 3. So here is point G, and then H is negative 2, negative 3. H, and then I'm connecting these going up and down. So line segments, distance between them will always be horizontal or vertical. You'll never have to figure out a diagonal. 3, 4, 5, 6. Distance between that one is 6 units. Continuing on, I'd like you to try those and then check in and see how you did. J to K. Better go green with this one, being that it's on the axis. 0 meaning you don't move. 2 you go up is J. And then K, 0 you don't move, but you go down 3. So this is right on the y-axis. J to K, 1, 2, 3, 4, 5 units. And then N and N, I'll go ahead and do that one. Different color here. 4, 1, meaning I start at the origin. 1, 2, 3, 4. Down 1, that's M. N is 4. 4, but then down 4, 1, 2, 3, 4. Being able to connect those and then count 1, 2, 3 units there. So you should be able to graph those and see how you did with that. If you need to pause it or watch this again to help, that's important. This example, finding these coordinates, there's a lot of directions here, so I want to go kind of slow here so you can see these. Rectangle ABCD is plotted on this coordinate plane. The coordinates of A are 1, negative 1, so I feel like that's important to go ahead and do that. A are 1, negative 1. Then they're going to give you the coordinates of D, which are 1, 2. So let's go. A was 1, negative 1. That was point A. D was 1, 2, that's D. Each unit on the coordinate plane represents 1 centimeter, and the perimeter of rectangle ABCD is 18 centimeters. So perimeter, we should know that means going around. A, B, C, D. In other words, they gave me A and D. I've got to be missing B and C, like A to B, B to C, C to D. Find the coordinates of B and C given these conditions. So let's do part A in green, and then we'll change colors for part B. If points B and C are to the right of A and D, so here's A and D, meaning that B and C are both over here to the right of this. How far to the right do I need to graph B and C? Well, they said the perimeter is 18. So what if I just count from A to D? How far is that? Let's see, that is 1, 2, 3. In other words, this side is 3, so we know this side over here also has to be 3. 3 and 3 would give us 6, but then we have to figure out how far over to go. It's a rectangle. What do we know about a rectangle? The opposite sides are the same length, so I've got 3 and 3 is 6. The total perimeter has to be 18. 18, what if I subtract 6? I'm left with, what's that, 12? So then I got to have this side and this side add up to both be 12. So that means each side must be 6. So if I go 1, 2, 3, 4, 5, 6, in other words, 1, 2, 3, 4, 5, 6, then that would be a point. And I'm going to go down 3. That's a point, and then this should be 6 to come back. Just double checking that that equals 18. 3 and 3 gives me 6, and then 6 and 6 is 12. And then 12 and 6 would give me, 12 plus 6 gives me 18. So remember, this is rectangle A, B, C, D. So if this is A and I go over, this has to be B, and this is C, and then this is D. So it goes back in that order. So if they're to the right, you would plot them over here. So what are the coordinates? Find the coordinates of them. Well, B's coordinates would be 1, 2, 3, 4, 5, 6, 7, but down 1. So coordinate B would be over 7 and then down 1. Coordinate C would be over 7 but up 2 in green. So that one's a little tricky there, having to do all that. So then they say, what if we do points B and C are now to the left of A and D? So we did the rectangle to the right. What would it be to the left? Well, it's the same rectangle. We still have to have a distance of 6 going this way. And so how far do I go this way? So you can count. You can go 1, 2, 3, 4, 5, 6. This would be a point, because it still has to have the same perimeter, still the same rectangle, still going up 3, still going over 6, so that we have the same dimensions as we had here. This was 3, this was 6, and 6 going around. So what would be the points of A, B, C, D? Well, A, if I go this way, this would have to be point B, and this would be C, and then back to D. So B's coordinates would be, let's see, 1, 2, 3, 4, 5, but that's to the negative, so negative 5. Let's see, negative 1, and then C's coordinates would be negative 5, but positive 2.